Okay, we're going to try to find the volume of the region bounded by the curve y equals x squared plus 1. So that's a parabola that's been shifted up 1 unit. And the line y equals negative x plus 3. So that's a line that starts up 3 units and then has a slope of negative 1. So something like that. Obviously, this is not perfect. Let me label these two. And we're going to rotate this about the x-axis. So we're rotating about here. So we're taking this region here. When we rotate it about, we'll obviously have some other piece down sort of here. That is not very good. And so if you look at any one slice, let's look at, get a color. If I take any one slice and rotate it, it's going to rotate into washers, right? We're going to have a hole here. Okay, so we know that the volume of such solids, since it's a washer, is going to be pi, and then we're looking for the outer radius squared minus the inner radius function squared dx with our appropriate bounds. So I knew it was a washer because my region was not touching my axis of rotation, and I knew it was in terms of x because I was rotating around a horizontal axis, the x-axis in this case. Okay, the outer radius is the distance between the outer edge of the region, so that's like here, to the axis of rotation. So we're looking for what function is this distance right here. So that's just the distance to the line negative x plus 3. So this part's going to be negative x plus 3 quantity squared. And then the inner radius is the distance from the inside of the hole there to the axis of rotation. So it's just that little distance between here and the parabola. So that's going to be the parabola, x squared plus 1 quantity squared. Okay, and now we subtract these two, and then we integrate across our appropriate bounds. So we still have to find what are the bounds. So I need to know what is this intersection point and what is this intersection point. I do that by setting these two equations equal to each other and solving. So that's going to be x squared when I add the x over to the other side and subtract 3 over to the other side. I'm going to be able to factor that into, let's see, x plus 2, x minus 1 should work. So zero product property tells me my two solutions are when x plus 2 is 0, or negative 2, and when x minus 1 is 0, which is x equals 1. So this must be the point 1 comma 2. Plug that into either equation to get that. And this is the point negative 2 comma 5. So for our purposes, we're looking at the x bounds, so we're going from negative 2 to 1. So that would be our setup, and if that's all we cared about, we'd be done. If you're interested in the answer, we get something like 117 pi over 5. And that's how that one goes.